Hello, thank you for joining. Have you ever wondered what blockchain is and what it can bring to your organization or to your customers? Well, you've come to the right place. Here at SUSE, we do believe that innovation comes when we put technologies in the hands of many. That's why we want to present you how you can deploy and manage a production-ready, enterprise-grade blockchain environment using SUSE Rancher and BTP Sextant. I am François-Xavier Houard. I'm a Partner Alliance Manager here at SUSE. Today with me, Louis Paul, one of our cloud solution architects, is going to do the demonstration itself. We also have a special guest, Duncan Johnston. He is CEO and co-founder of BTP. Is going to tell you more about the BTP Sextant solution and the broader DLT landscape. He's also hosting another presentation for this SUSECON, so please feel free to watch. Without further ado, what is DLT? What are we talking about? Well, in order to understand blockchain and DLT, we have to come to the source of it, a trusted ledger. And it's not an innovative thing. Actually, it's been there for centuries. A trusted ledger, basically, it's a list of records that tells an unambiguous story that you can use as a proof of truth. And everybody agrees on it. Civil registries, for example, bank account, cadastre, criminal records, corporate accounting, you name it. What we need from a trusted ledger is that it tells a consistent story so that it makes sense, and it's immutable. Any record registered into the ledger has to stay in the ledger the way it was recorded. And of course, each of those records need to be valid, right? Well, those things were pretty easy to do when it was relying on books. But now, in the digital world, there's a little bit more complexity. The reason why is we have immutability. This is a key requirement. We just discussed it. But to make it happen on digital world, it's more complicated. Actually, anyone that have physical or logical access to the place where the data is stored can virtually change it and therefore change the past. So to compensate for that, to prevent that from happening, we do implement security measures. You know them, they are costly, complicated, but it works at the end of the day. But who is going to enforce those security measures? Well, a ledger owner, of course. But what we mean by that is that each ledger has to be owned by someone. The problem with that is that many times, the full story involves many stakeholders. And each stakeholder will want to have its own part of the story stored in its own trusted ledger. So we don't have multi-party ledgers. Basically, it doesn't really exist. Instead of that, we have information scattered and fragmented in many ledgers. Just think about making a payment over internet using, let's say, PayPal and your credit card. So your credit card company is going to store a record of the transaction. PayPal is going to store a record of the transaction. Your bank is going to store the record of the transaction. The receiving end bank as well. And of course, the website where you made the purchase. So at the end of the day, the story is fragmented. And it generates opacity because it's really difficult to really understand what happened. And most importantly, it prevents any kind of ledger automation. Because every stakeholder only owns bits of the story. So you cannot really make an automation when you know that 90% of the story is out of your hand. This is why we have distributed ledger technologies. It's really about creating multi-party trusted ledgers. And of course, blockchain is the best known type of DLT, but it's not the only one. Well, DLT are changing the game, and the implications are deeper than you may think. Well, how it works? Basically, it's about bringing trust by design. So instead of having to secure the place where data is stored, the blockchain itself secures the way it is stored. And the way it works is pretty impressive. And just to give you an idea on how secure it is, just think that there are more than $1,000 billion worth of assets in the Bitcoin blockchain. And should anyone be able to change the past, you should be able to claim ownership for each of those blockchains. So we're talking about a $1,000 billion kind of hack. And so far, it has never happened. So it's pretty strong. And what it implies is that you do not need a single owner anymore. We can trust the technology. Instead of trusting someone to secure the technology itself is secured by design. So you can have multi-party ledgers. You can have several parties sharing the same data layer, the same ledger. What it involves is that it's easy to automate. Because the full story is in the same place now, we can implement automation. And what it means, you can have some kind of contracts that you are making with the blockchain. And the blockchain is somehow committing on the fact that what you have requested will be executed whenever the conditions you have decided are met. So you basically say, when those conditions are met, I want this piece of code to be executed on the blockchain. And you know by design that is going to happen. No one can prevent it from happening. So let's take a step back. We have a data layer that every party trusts without having any owner. You have an execution layer that everybody trusts. So you have a runtime for multi-party applications. That's exactly what you have. And that's pretty amazing. If your mind is not blown yet, I don't know what I can do. Because what it unlocks is a new broad range of solutions to problems we've been used to solve otherwise. And some of the solution is going to be incredible. The potential use cases are very numerous. Of course, if we only focus on the data layer, the trustworthy multi-party data layer, so the multi-party ledgers, they can easily replace the existing data layers that are scattered across various organizations in an industry. So it can work very well in finance, insurance, supply chain, administration, you name it. But if you take multi-party applications, the consequences are even broader. Everything that involves trust sometimes involve third parties that are mostly bringing trust as a service. This is what we call the platform economy. When you talk about Amazon, when you talk about eBay, when you talk about Kickstarter, all of those guys, what they're doing mostly is adding trust in a transaction that you could have directly hands in hands otherwise. But you need trust because you're using internet. Well, with blockchain, you can imagine that you can do that without those third party involved. Of course, the whole bank systems are subject to be reviewed with the multi-party application potentials. As we speak, there are hundreds of companies trying to rebuild bit by bit everything that your bank is doing using blockchain technologies. This is what we call decentralized finance. And of course, we have the same for insurance. Even internet is being reviewed with blockchain technologies. Things like DNS or referencing are being rebuilt using smart contracts on blockchain. We don't exactly know what is going to work and what is going to fail in this broad scope, but we know that it really opens up new ways to consider problems and to solve them without having the need of a third parties that just provide the trust. So that's pretty deep. Of course, if you want it to work, it has to be sustainable. The good news is it can be sustainable. Well, so far, Bitcoin hasn't been a very good example. Many of you have heard that. It's really not sustainable as it is, especially if we think of blockchain as a commodity for the future. But the good news is the reason why Bitcoin is so bad in terms of sustainability is because it was made based on design assumptions that were very naive. Now that we have a track record, we have a better understanding, we can build blockchains with way better and more energy efficient approach. Ethereum, for example, is, as we speak, shifting from a previous design to a new design, which is by itself reducing by 99.95% the power consumption. And we can even expect further improvement in the future. So it can be a sustainable technology. Cool. But what about enterprise adoption? Well, most famous DLT, like Bitcoin or Ethereum, come with limitations that can prevent immediate enterprise adoption. The energy efficiency, we talk about that. We are on the good path, but it's not done yet. The throughput, which is usually pretty small compared to what we need. Access control, Those blockchains do not have any kind of access control mechanism. And of course, inclusion to broader IT landscape and service offering, because it's open and there is nothing specific to your industry or to your organization in those DLTs. All these DLTs have something in common. They are permissionless, which means everyone in the blockchain is a first-class citizen. No one needs to register whatsoever. It's highly democratic, it's very open, it's kind of radical, but it does not necessarily fit what an enterprise needs. And that is why we have permission DLTs. So permission DLTs, basically, they are permissionless DLTs plus access control. And because you have access control mechanism, you can implement very, very efficient algorithm for validations, which can reduce their energy consumption and increase the throughput dramatically. Plus, it enables deeper integration to your existing IT landscape and service offering. So you are bringing new capabilities to the blockchain for enterprise usage. Pretty awesome. And the good news is they are usually open source. Great, no? Okay, but there is one small hiccup. They are kind of complicated to implement because they rely on several components. It's pretty new technology. Everything needs to be tied together. So putting your hands on it may not be very easy, especially given by design, we want it to be decentralized and scalable because it's all about decentralization. So you want it on Kubernetes. So how do you do that? Well, we're going to present you how you can spin up and manage an enterprise-grade, production-ready permission blockchain deployment on Kubernetes, leveraging SUSE Rancher and BTP Sextant. I hand it over to you, Lois.
Thanks, Francois. Now I'm going to cover how we deploy a blockchain on SUSE Rancher. And what I want to cover here is to show you how different it would be if you had to do all this by yourself, and how Rancher can help you in automating a lot of the procedures here, and also providing a complete enterprise solution to blockchain. So now, the first thing that you want to do when you're starting to create a blockchain environment is to make sure that you prepare ahead how you want your cluster to be defined and all the other steps that you're going to take to make it highly available, as well as being able to make it resilient. So what is entailed here? Well, you have to figure out the amount of resources that you're going to use. You're going to have to make some decisions on the automation tools that you're going to use to actually create the cluster and maintain it, not just day zero, but day one and day two. Operations that you want to do with them. And then once you're done with that, now you have to figure how to configure and deploy your distributed ledger technology. So that also requires quite a bit of design work and thinking ahead of time. And once you have a plan and you've executed on your plan of deploying your distributed ledger, now you have to go and decide what you're going to do for notifications of for monitoring of your services, and also how you're going to integrate it with your service management system. So that's quite a bit of prep work that you have to do to get started, and this is just infrastructure-based things. Once you have all this done, your infrastructure is up. Now you have to figure how you're going to maintain it over time, as well as how you're going to prepare and offer this environment to your both on your development side and also for the runtime for your customers. So that's quite a bit of work. And here's how, with the partnership with BTP, we have simplified a lot of this and created an environment where you can do this all at a very sophisticated enterprise level. And now you can focus on creating your smart contracts, leveraging your blockchain to create your applications that will benefit your customers. So for Rancher, we've drilled it down to doing one-click deployments. When I mean one-click deployments, it will be clicking on a function in Rancher and then entering a few fields that you need to have some options in terms of configuration for your cluster. All the deployments of all the components are done via the packaging manager of Kubernetes called Helm. So that simplifies the maintenance of how you're doing all these automations over time, and you can put all this under source control and see how you're changing your implementations and potentially do all these things now that you're dealing with blockchains that containing quite critical enterprise and customer data. You want to be able to ensure that there's audit trails of all the environment change. So all this with Helm charts will be able to be managed via some source control and auditing trails. And now you want to use a good UI that is going to help you configure and maintain your distributed ledger itself. So this is where we're going to show you how this is done with Sextant. And then the whole underlying infrastructure needs to have some DR and backup policies that meets your business needs. You want to be able to also be able to scale that environment and upgrade everything over time. So let's go directly and start showing this through the UI, and I will cover the best practices of what we did while we were doing this. So I'm logging in right now to a VM from which I'm running all the views. So I have a Rancher running, and I have 3 different clusters that I've already set up. So that's to expedite doing this quick demo. And once these are done, and you can start installing Sextant, and then you can start installing your DLTs managed by Sextant. So I have right now Sextant already installed, and I have 2 DLTs. But let me go through the steps of what it took to get to this point. So the first thing I had to do is to install Sextant. And Sextant is now available in the SUSE Rancher marketplace. So if you go to the app view of Rancher, this is not. I may have to refresh and relog in here. No, we're good. All right. So if you go into the app view of Rancher, this is the marketplace, and underneath the partners is where we have Sextant. And the installation, like I said, is it's a one click, but with a couple of input that you have to put. So you would decide where you want the Sextant to be installed. Usually you would put all the Sextant components in the namespace, so then you can protect that namespace and allow the Sextant administrator to be able to install in the namespace. I already have something created for Sextant here. And then the next step is to be able to answer a couple of things about credentials to get access to the binaries for Sextant that are in registries. That means that's all the containers that Sextant is using. And then you have to make some decisions about whether you want to set up some ingress rules to be able to access Sextant, as well as whether you want to host the database in your Kubernetes cluster, or you may have an external database, in which case you would have to provide some details about where it's hosted. So for this demo, actually, I was going to show you that you did both. One of them was to have Sextant using block storage that is provisioned by Rancher itself using a product called Duncan, and I'll show you why this is useful. And the second one is I have an instance that is running where I have my external database. In this case, I have a database running in Amazon RDS, where it's a managed service for Postgre there. So Sextant, you just needed this, and then once you've completed this and you run the install, is you basically end up with your installation, as I mentioned earlier. So we have the service running, and you can see um, that Sextant is already installed, and you can see the details of Sextant running, all managed from the Rancher UI. Now, what went on in behind the scenes here is that the um, for Sextant to be able to get the right resources, I have set up very specific storage. So in this case, this is a block storage, distributed block storage that's cloud native that we call Longhorn. It's a SUSE donated project to the CNCF. And within Longhorn, I had set up a few nodes. For this demo here, I just set up two nodes to show that I would have enough redundancy, that no single point of failure for my. And the volumes that Sextant required, um, in this case, this volume claim is using Longhorn, and it's spread over two replicas. Now, we talked a little bit about the need to back up and make sure all this is ready for eventuality of disaster recovery or continued business. So you can all these, because these are block storage that are spread across multiple nodes. These can be backed up, and you can actually create as well um, different backups to actually have your disaster recovery volumes in different regions, and then be able to copy the volumes that you're using from what is running in one region to the other. So you have all this done already ahead of time. So there's no after thinking here. So once you install Sextant, you have all the components that you need to be able to ensure that there's no loss of data, and you can recover in case of catastrophic failures. The second thing we talked about is once that you have your infrastructure set up, you want to be able to monitor. So within SUSE Rancher, we have some dashboards created automatically. And what I have here is a few dashboards. One that will show all your nodes and aggregation of your capacity on all the nodes that you're using to run your DLT management, Sextant in this case. And you can also look at the clusters where you're going to actually deploy your distributed ledger as well. The second dashboard is a view of the resources that the application or the service that Sextant is running itself. As I mentioned, Sextant is deployed as a Kubernetes stateful set, so you can, and we contained it into a namespace. So now we can look at all the resources being used into that namespace, and you can create alerting and everything directly. So this is all out of the box. With Rancher, I just had to pick which resources I want to take a look at. So quick other thing on Longhorn here that I just mentioned, it's a critical component, I think. It's a best practice to get your storage figured out ahead of deployment of all this. So if you go to longhorn.io, you'll see the details of how Longhorn technology works and how it enables to have different block storage provisioning that is managed by engines that run within Kubernetes themselves. So there's nothing outside of Kubernetes in this whole solution set, which leads me to talk about one more item. Once those clusters are set up, the state of the clusters are kept in the etcd database. So it's critical for you to be able to, out of the box, be starting to back up etcd. So let me give you a quick view here of how I achieved this. So when we created all the clusters, the best practice again from a say Rancher standpoint is to create those instances of your Kubernetes clusters by using things that we call node templates. So node templates is a way to define how you want to define your Kubernetes cluster. I'm going to go quickly over uh, the definition of the RKE template here, and you will see that that's how you get very fine-grained definitions of the version of Kubernetes that you want to do, what type of CNI um, you want to use with your cluster, and then if you need an ingress controller to control some of the ingress for the services that you're running, in this case, Sexton can run uh, as a service, and you can configure the ingress to go to that service. And the one I wanted to point out is once you've defined your Kubernetes, your clusters as node templates, you can define where you want your backups to go of your etcd database so that you can recover the state of your cluster. So I have done that for the templates uh, for the Kubernetes cluster that I'm using with Sextant. In addition to this, there are the things for security. We talked about setting up things day one to be secure. So I'm running on top of this cluster CIS benchmarkings checks that are running every day, and you can get reports of this and see whether there's anything that is of concern from a security standpoint. And I'm protecting direct access to the API server with certificates. So this is, a way how Rancher can help you templatize creating your clusters, and then you can also templatize um, how you want to create uh, the, the granularity of your cluster based on your requirements from a capacity standpoint. So I have separate node templates for my control plane, for the Longhorn nodes that I'm running, for the distributed block storage across different AZs, and my worker nodes where the actual DLTs are going to run. So now let me give you a quick look at something else here, which is going forward. Um, in Rancher, we have now implemented creating clusters using the new Kubernetes cluster API. So what I've done here is I've leveraged this new facility that's available now from Rancher version 3.2.64, I believe. And I've created basically a way to self-service on creation of your blockchain cluster that will have the same level of granularity of definitions of what CNI, how you want your backup uh, scheme to be working, and you can add also things how you want monitors and dashboards definitions in there. And all this is done now with a Helm chart, and I expose that Helm chart via the marketplace. So it can now get even simpler to create those clusters on top of which you're going to run either Sextant itself, or you're going to run backend services that is necessary for your applications. And in this case here, I'll give you an example. I'm going to set up a cluster that is going to run in US East 1. And scroll down. And it will leverage picking up my credentials to be able to use this particular cloud provider. And once I'm done with this, behind the scenes is a lot of the templating that's it's referencing. And with a one click, I have a best practice in terms of security and everything that I want to do with setting up a cluster for my distributed ledger that is actually getting provision. So it takes a couple of seconds to be able to see the cluster. Let me go and refresh. And that cluster should be provisioning now. See, it's a blockchain cluster. And within a few minutes, it will have created this into the Amazon environment. So, so this is how you get to apply best practices. Template everything, have all the stuff that you need to do to be able to maintain this as an enterprise solution. Basically, day one, like configuring these things fairly simply, and then behind the scenes, everything is getting managed uh, within within Rancher. So let's go back to Sextant now. So you've seen how it is that easy for us to install Sextant itself on top of an arcade cluster, and that arcade cluster has all the enterprise readiness to it. It's running as SHA. It's also running with backup strategies, and also the clusters are set up to be able to have things like CI scans for security and so on. Now that you have everything running and you know that you have a highly available and non-tamperable cluster, you can now start adding additional clusters. I already created a few, but just go quickly to show you that it's within Sextant now. You can now start creating new clusters, and then once you've registering new clusters, and once you point to those clusters that, for example, had been created by the automation I mentioned earlier, then you can now go and look at your clusters and what is installed on top of them. So I have three different clusters here. One of them I set up specifically to run DAML contracts. It's using Sawtooth as DFT. And then the other ones are just running plain Sawtooth. So let's take a quick look here on how we create new clusters. So let me go into the cluster that we're using. So as you can see, there's 4 nodes. They are running with very specific endpoints. And these nodes are what is forming the Hyperledger network. And on top of this, now you can start deploying very specific um, Hyperledger implementation. So for the versions that we have right now in the marketplace, you have a choice between the flavors of Hyperledger from Besu, as well as the one from Sawtooth. And then on these Hyperledgers, there's further integration with DAML to be able to run smart contracts. So what does it take to actually launch a new Hyperledger instance? Is as simple as, and I'll pick the one DAML for Besu here. Just a matter of giving it a name. So I've used that name before. Put it in again. All these are Kubernetes-based deployments, so things about namespaces and stuff like this relate to resources in Kubernetes to host those. So and I leave everything else as default, but you can adjust them as needed for your. There was one additional option that I want to show you after I deploy. So now that I've done this, you have a cluster that's on its way being deployed onto the Kubernetes environment. And on top of these clusters now is how you can start creating smart contracts. So you can define from there different parties. I created 2 ahead of time, which is SUSE BTP and some things with financial open source consortium. So you could have create smart contracts where you have two parties participating in a transaction, and those are running between them. Um, and to deploy your smart contract, they are deployed as packages, and you can just upload and start deploying this into those clusters. And here you go. You have a highly available environment with all the um, things necessary to be able to start um, running those smart contracts. So, so this is again a quick walkthrough through how we install a blockchain on top of SUSE Rancher, and hopefully that gives you kind of a overall idea of how simple we've made it from an interface standpoint. At the same time, how everything behind the scene is resilient with the quality of service that you're expecting for an enterprise solution being deployed onto Kubernetes. And now I'm going to switch over to um, uh, Duncan, who's the CEO of Blockchain Technology Partners, and he's going to talk about the landscape for blockchain as well as how we see future integrations done between SUSE and Rancher.
Thank you very much for that excellent demonstration, Lewis. Also, I think you make a brilliant case for the combination of BTP Sextant taking care of blockchain management and, of course, SUSE Rancher taking care of the Kubernetes management that underpins what we're doing. So what I'm now going to do is take a step back and actually look at BTP Sextant in the context of the broader distributed ledger technology landscape, or DLT landscape. So let's briefly recap what we at BTP are focused on. So really, we see ourselves as enabling multi-party innovation. The goal here is to provide a platform, again, very similar to the way in which SUSE Rancher thinks of the world, that takes care of all of the underlying heavy lifting, so that from a business standpoint, you can just get on and exploit the benefits of both distributed ledgers, smart contracts, information security, and of course provenance. So that's really, when we talk about BTP Sextant, that's really what we're talking about. So as you will have seen, it's a Kubernetes native blockchain management and operations platform. One of the key things is that it gives you a great deal of choice. It allows you to deploy and manage a variety of permissioned and hybrid open source DLT stacks. And this is very exciting, and we cover this in a tutorial, also at SUSECON, 1203. It's also available through the SUSE Rancher marketplace, which is a great innovation that came in with SUSE Rancher 2.6. So again, this makes it extremely easy for us to partner with SUSE Rancher, and for you as a SUSE Rancher user to get access to BTP Sextant. So when we talk about an enterprise blockchain stack, what do we really mean? Well, we mean providing support for not just the distributed ledgers themselves. Of course, that is fundamental, but also overlaying on top of that support for smart contracts. And we've opted to support DAML, the smart contract language from Digital Asset Holdings, and WebAssembly, which is a product of W3C standards initiative, sometimes known as WASM. And the idea here is to provide support not just for the DLT, but also for DAML and WebAssembly. And then again, in the context of information security, ensuring that you can back file storage and document management systems with a DLT. And so that's precisely what we're doing with partners such as Tachyon, who have a decentralized file system that presents just as a normal file system should, but is backed by Hyperledger Sawtooth. And this is very exciting for us, provenance. So we support something called Chronicle, which is our own ledger agnostic system for really capturing all the key information around the provenance of assets. So the language is the language of assets, agents, and activities. And this is drawing on the work of Prov-O, the provenance ontology, also from W3C. And that work is being led by my co-founder and our CTO, Kevin O'Donnell. So we're very excited by Chronicle. We see it as opening up a tremendous range of opportunities for us, but more importantly for people using B2B Sexton, because it very quickly lets you get to grips with tracking the provenance of assets, be they digital, be they physical, and also ensuring that that's backed by a ledger. And then, of course, being able to reason about those facts. So, what activity took place, what agent or agents were involved, and what was the asset in question. So now if we zoom out again a bit more, there's some work that Chilo Zigri, our VP of Strategy, has created and curates called the DLT landscape. Top right, that QR code will take you to the DLT landscape itself. But what I'm doing here is just showing where we fit within that overall landscape. So there are many companies, many projects, many initiatives covering a whole range of different areas. But the key for me personally is the work that Chilo has done really does make it easier for people to understand the taxonomy. So what are the different layers in the stack, starting with the compute infrastructure. So that's obviously Kubernetes for the most part. And that's where we're working with SUSE Rancher. And then layering in the distributed ledgers themselves, intersections with other technologies, blockchain databases, distributed storage and file systems, but many others besides. And then interop, smart contracts. And then within the application tooling layer, that's where Chronicle sits. And at the very top, you can see some examples of some customers of ours that are essentially using some or all of these components and using B2B Sexton in order to deploy and manage them. So that's really all I wanted to say, just to sort of provide a bit of context, and would just like to say on behalf of Francois, Lewis, and myself, a big thank you. So thank you for listening, thank you for paying attention, and of course, please don't hesitate to reach out to any one of us if you have any further questions. Thanks again.